Hi, David. How are you? And welcome to the Real Talk.
Thanks, Rob. Great to be here with you.
Oh, it's so fascinating. I know we tried to set this up last year and times and things and schedules didn't match, but you're here in 2021 and we've hit the supply chain disruption.
A little bit.
Coming down off the COVID, I would say hopefully we're off the downhill of the pandemic and going into a whole supply chain disruption that's come around. So, but I'm really happy to have you on, as I know you've have a lot of accolades in the industry. And why don't you tell a little about the audience of who you are and how you came from, a little bit of background.
Oh, super. I started my career as an electrical engineer, did some design for a few years while I got my master's in management, and got into the semiconductor business in the early 90s with Xilinx, first as a field apps engineer, then worked my way up through the sales management ranks. Had the privilege of tour of duty in Asia. I ran Asia Pac for about 3.5 years for them, came back to the US, moved to Silicon Valley and ran a couple of business units for Xilinx. Then I stepped back onto the worldwide sales and marketing role with Intersil, then a stint with Cypress, and finished up my career with running worldwide sales and marketing for Maxim, and retired in the end of 2019 and thought I was going to be really just spending my time on the golf course, doing a little bit of consulting, maybe a little board work. And this opportunity popped up. It was really interesting. Bill Bradford, my predecessor, is a good friend, and he was going back into the industry, and he somehow talked me into leading ECIA, but I'm thrilled. I'm having a lot of fun with it. About a year into this role, and it's I think really a great opportunity for me because, number one, it keeps me really in touch with the business that I love. That's been very good to me for 30 years, and it gives me an opportunity to really give back to such a great industry.
Yeah, I cannot agree. I mean, with the experience and history that you have, and many different semiconductor companies that are really powering the world today. I mean, it's fascinating. Some people don't know. I mean, some of those companies, Xilinx, I think you are Maxim or Cypress, you had Intersil, you had stints everywhere, and those companies are powering the digital world today, which
Absolutely.
is in that knowledge. And thank you. And these are things of sharing that knowledge, that wisdom, and to the new industry, to the existing, to new generation coming in, of what was exciting out there. And also, I know you were, as I say, you were in Asia. I think you were in Asia in the early 2000s, right when the whole Hong Kong, China boom, industrial revolution happened, correct?
Absolutely. I was very fortunate with the timing of being in Hong Kong. We were asked to take that tour of duty really right in the wake of the dot-com bust. So at that time, all the major global electronics companies were trying to get to Asia in a big way. Obviously, people trying to try to tap the international market, but also to be able to potentially offshore and lower costs of development and so forth. But it was also the time of the upswing in ODMs, like the Quantas and Compals of the world, and Foxconn. But it was also the tremendous growth trajectory for the Chinese communications companies like Huawei and ZTE, and really when guys like Samsung really became a prime brand in the worldwide electronics market. So I really count myself as being tremendously fortunate of having that opportunity to go to Hong Kong. And it's interesting because my wife wasn't that probably wasn't her first place that she would want to take an international assignment, but it turned out to be a wonderful experience for the family. And overall, it's just a tremendous experience personally and professionally.
I cannot agree, because that was when my father was taking me early 2000s, late 90s, 2000s to Hong Kong. And that's where our first office was set up. And that's where I learned everything. Going to factories were all in high rises, and everything was there before it all moved to China. And it was so fascinating going one building going floor to floor, different production, the commodity, the procurement, the engineering, everything was done and built. Concrete jungle, as everybody say, it's the concrete jungle. It's the, New York and Hong Kong, those are the concrete jungles, the financial world, and it was fascinating. But yeah, of course, Hong Kong is probably one of my favorite places in Asia. Of course, set politics aside now, things have been changing, but it's beautiful. It's expat community. Everybody's there for a reason, purpose. It's the food, the transportation, the MTR, and all the things that have there. It's unbelievable. So
it is, and so we called it Asia for beginners.
yeah. Yeah, to get your feet wet and before you jump into, especially in early 2000s, China was still, that Lowu or that Futian, Shenzhen, that whole area was in the process, and it.
Now they're beautiful metropolises. It's really amazing to see how those cities have come along. Actually, you look back, Shenzhen was a sleepy little fishing village 40 years ago, and now it's really one of the major industrial complexes of the world, and they've done a nice job making it very, very pleasing place to live.
Oh, as you know, it's the Shenzhen. There's quite a few facts I'll share quickly. Is like, I think it's the green city of China. It's the first city that everything is going green. They want to get all public transportation is electric. Most of, I would say 90% of it now, and also that's a Silicon Valley. That's where a lot of startups and incubators are coming around, and it's fascinating. I'm like, we should have just moved here 20 years ago, and I could have all this, but things are changing. So it's every time I travel, I haven't traveled there for over a year now, but it's fascinating, the infrastructure and how fast they build. Of course,
it is.
The culture is different, the governments are changed, a little very fast forward. But yeah, it's things are happening. Saying the things are happening out there. So very good. Now we get into, as I said, for the ECIA. Tell us a little bit about ECIA and how you actually got in that world. You tell a little bit about how you got in the role, but the ECIA and what's the foundation, how it was created, and what it does for the distribution manufacturing market.
Sure. So ECIA is pretty unique as far as trade associations in the U.S. Most trade associations cater to one specific constituency. I was involved with SIA for many years, the Semiconductor Industry Association, and that's all really semiconductor executives, mostly CEOs and top management that take part in that. And they're really focused on, like a lot of trade associations, on public policy issues in Washington, D.C. They do a lot of great work in immigration reform, on intellectual property protection, on forced intellectual property transfer, things like different trade policies and so forth. So ECIA is been around for nearly 100 years now. It actually started out as a distribution association in the early days of radio. And so a group was formed and actually became NEDA, National Electronics Distribution Association, back in the 50s. And there was another trade association called ECA, the Electronic Components Association, that formed almost the same time back in the 1930s. There were component suppliers to the radio business. And those two associations came together in 2011 to form ECIA. And what really makes ECIA unique, and what's really appealing to me, is the fact that it's not just one constituency. It's we have manufacturers, and those manufacturers include semiconductor manufacturers like SIA. A lot of people are members of both, but also IP&E, interconnect, passive, and electromechanical manufacturers. So we've got people that make anything from capacitors and inductors to electric motors and so forth. But so that's a manufacturing arm. But then we also have a very strong distribution constituency from the origins of NEDA, and we also have independent manufacturers rep firms as well. So, the real purpose behind ECIA is to be able to help promote the authorized channel, to be able to help people, customers of electronic components, come investigate and buy from authorized sources, so that we can try to avoid counterfeiting. And also, it's about solving in a cooperative fashion the kind of everyday issues that sort of dogged me for 30 years throughout my career. We talk about different ways to be able to work together between the different groups to be able to streamline, paperwork and business reviews and everything from the way that businesses that the channel works with manufacturers and beyond. We really work together in a cooperative fashion. And ECIA itself is just a very small staff. We've only got 9 direct employees. We really depend on the passion and commitment of the representatives of our member companies to ECIA to really work with us to be able to get a lot of really good stuff done. And so we're so appreciative of all of our members that get involved and really work together. Hey, I was on that side of the fence for 30 years, and they all got very, very busy day jobs. And they're willing to sit on council meetings. They're willing to sit on board meetings and work together with our Global Industry Practices Committee, which is really a place where we get a lot of the work done. And we're fortunate to have a very, very strong senior staff of people that are direct with ECIA, but it's really with the expertise and commitment of our members that want to work together to be able to solve these problems so we get things done.
Yeah, of course. I mean, I look at it that it's like a think tank that brings up, or if ECI is like a facilitator. They bring in all the great minds of all these semiconductor distributions, like a think tank of what's the next strategies, what's going on, the evolution, and of course, keeping all the compliances in order, the compliances and how we behave in the work process, because especially going from I would say analog or to a digital world and everything has changed. There's so much more information out there, but it's like, what's the real information? And now ECI being a trusted source, I'll just say authorized distribution, giving the latest information. So it is, you guys are leading the industry. I mean, I know there's a lot of other people that feed in, but it is good to have that brand. And I'm glad that actually have you on to talk about this, because myself, we've been a part of ECI for many years, but
we appreciate that.
Yeah, using it and understanding it more. And, at the end of the day is being where the people are at, being in the middle, what's going on, and understanding the new technologies in place. And of course, when M&As happen and everybody's consolidating, it's exciting at the same thing, what's changing. And you guys are the news outlet that can let people know, like, this is what's changing, this is what's happening, and how these acquisitions happen and what it means for the industry.
Absolutely. And so in addition to the cooperative work we do together, obviously to help make the industry more effective, more efficient, and we also provide a lot of information to membership. We're very fortunate to have a great chief analyst in Dale Ford, who's works across the membership and even beyond the membership to really try to identify the prevailing trends and really be able to provide a lot of useful information to the membership to help guide their business.
Oh, it's just fascinating. Well, thank you and the whole team for the work, and thank you for, off your retirement now, giving back. This is really where that comes into, is how you landed this position, but as leading the pack and using that knowledge to really quantify people and help the industry out that's supported you and give you a successful career.
That's right.
Yeah, successful career. So now jumping into the supply chain side, quickly, going into, from 2020 to 2021, right now I gotta say, how has COVID-19 pandemic, as you say, generally affected the semiconductor industry?
Well, for semis, it's really, you could include IP&E in this as well. Certainly, COVID impacted the industry and the supply chain. If you look at it, semiconductor companies, just like other manufacturing companies, had some disruptions, some issues with having to shutter for weeks to months to be able to try to put protective measures in place to keep workers safe. And but really the electronic components business, semiconductors and IP&E, were all pretty much back to pre-COVID production levels by Q3. And it's really some of the interesting challenges we have right now is obviously there were a lot of other businesses that were customers of the electronic components industry that had shuttered, and some of them for longer than others, and had it was an interesting dynamic about the timing of COVID, because I think, as most of the listeners probably know, the overall business went into the downturn at the end of 2018, and 2019 was a pretty soft year until toward the end, and it was actually just nosing upward when COVID hit, and all of these businesses were impacted by that. So, what COVID did was created really a delay in that upturn. And when the upturn did come, really in Q3, as businesses started really getting back to work and people started to ramp production, then a lot of the supply chain issues really started to bite. And now in the beginning of 2021, we're realizing that this uptick is very strong, much stronger than many previous recoveries. In fact, Dale Ford was sharing with me that really the current recovery is trails only the three periods in all of the semiconductor and electronic component cycles that we've had over the last 40 to 50 years. And that's really trails just the coming out of the dot-com bust, coming out of the financial crisis, and back in 1986 when the industry was very, very small. So just from a rate of expansion, the amount of orders being put on the books now are incredibly, incredibly strong, as businesses really understand that COVID was a temporary lull, but that acceleration that was happening in 2019, we're actually making up for lost time in that acceleration. Everyone's scrambling for parts right now. Lead times are stretching. And so a lot of people are screaming about trying to get their electronic components.
Yeah, I mean, to elaborate off that, that's one thing I look at. It's like going from 19, it was a soft year, going to an upsurge in 2020, but we got hit by COVID. But one thing is, last year, I think the BCP plan, business continuity plans, really, you saw who had them in place and who didn't. And a lot of the subcontractors and contractors for all the component fields, from the manufacturing to the component manufacturer side, I think that really separated the men from the boys of, people that been in this industry for so many years, but they did the same thing every single day, and they didn't realize you need to invest to have those, to avoid these type of disruptions and mitigate.
That's right.
Disruptions, right? And that's really where a lot, as you said, the PPE came in play. That no matter what, that no one knew they need PPE, but at the end of the day, it's just like manufacturing lines down, challenges with natural disasters, because I think we had some fires in some other semi-fab house. A lot of things happened in 2020 that's still affecting the upsurge that's going on now. So for us, that's one thing that I always talk to the customers is it's funny, we learned that from a lot of our international customers, a lot of the big guys. They audit distributors of their BCP plants, make sure they have redundancy in place, they have warehousing in place. But of course, I think in other areas or other countries are smaller, they don't do that to their suppliers to also align them with their needs, which cause disruption in that supply chain, from basic raw materials or basic things are going into into the component electronics as it expands. So I think it was an eye opener for everybody, and it's like we weren't ready, and I think that's one thing. It's kind of I would say slap in the face, like where we were. We're so advanced, but we weren't even ready for something.
Yeah, the semiconductor market and the electronics market as a whole tends to run on a 4-year cycle. Mm-hmm. You just have boom and bust on, and you look. This tracks for more than 30 years. You can see that, and maybe move in and out 6 months, a year or so. But if you look at most of the major cycles over the last 30 years, it comes and goes in 4-year increments, and it's just amazing that that there's this factor of amnesia that also impacts people every 4 years. I think probably everyone expects, okay, well, I'm smarter this time, and so I'm going to know when that next upturn is, and so maybe I don't need to put the backlog in place. Maybe I don't need to be sitting on as much inventory. And then they find out, oops, I really should have had better advanced planning. I should have been buffering more for this kind of upturn. And so, a lot of companies are going to be caught short. One thing that you obviously know is that the automotive companies are screaming about component shortages, and certainly economies are being impacted by tens of thousands of workers being idled because they can't get their hands on semiconductors and other electronic components that they need to be able to build cars. And, it's crazy if you think about it, that an $80,000 vehicle may not be able to be built for lack of a $2 microcontroller. And I've had a lot of experience with this over my career. And, I talk about that amnesia. People tend to plan around steady state business, and maybe take a step back and talk about these 4-year cycles. These boom and bust cycles have been such a continuing thing that no one in the components business really wants to build for the peak. They can't. They just wouldn't make money, because when you're talking about anywhere from $3 to $5 billion for a 12-inch fab, 300 millimeter fab, you can't build for the peak of demand and then in steady state upcycle be running at 70-80% utilization, and then in a downturn run at 40 or 50% utilization. You would lose money. You would have to charge customers far too much for the components to be able to cover that amount of capital expenditure. And so really the semiconductor market and most of the electronic components market, especially where it's really heavy CapEx, is going to size themselves for what they expect the steady state demand is. And when we have these snapbacks like we're having right now, lead times are going to stretch just because you can't get that much product through the manufacturing pipeline. Now, it'll take 6 months, 9 months. I mean, at the outside, it may take a year to be able to catch up to all this backlog. And then you can argue, well, is all the backlog really valid? Because certainly when there are shortages, then people start double ordering, and there's all kinds of games that are played up and down in the supply chain for people to try to get product. And so it's going to take a while for that demand to catch up, and then we will be sized right for this for the remainder of the upcycle. So from a component perspective, lead times have stretched a fair amount. Semiconductors normally run about an average of 9 weeks, and they're up around 13, 14 weeks, according to Dale's latest numbers. Passives have spiked by about 3 or 4 weeks. That's the average. Interestingly enough, the electromechanical doesn't and interconnect doesn't seem to have stretched quite as much as semiconductors and the passives business. But those averages, while they're stretching, it doesn't talk to the extremes. There are certainly guys that deliver, especially like microcontrollers and discretes right now, that are stretching far beyond 26 weeks. Some reports of 40 weeks, some reports of over 52 weeks in lead times. And so, businesses that have seen these cycles so many times, our customers for the electronics components should, number one, hopefully have learned from previous cycles and be able to really anticipate and be able to put backlog on in a timely fashion. they should also take advantage of the resources that are available to be able to help buffer these kind of situations.
Right.
The channel is there for a reason. Your business, your family's business, all of the distributors around the world are the sanctioned vehicle, if you will, of the electronic components manufacturers to be able to help people get through these these spikes.
Yeah, buffer the gap. They can
You
feel
guys buffer it. You guys are sitting on anywhere from 6 turns to maybe even, some guys sit on 2 turns
Mhm.
of inventory, specifically to be able to help customers smooth out these rough spots. And the challenges, I talked about this amnesia. Each time you get to a steady state upcycle, then you have customers that are going to manufacturers and they're beating the manufacturers and really holding a gun to their heads at times and saying, I will do business with you only direct.
Yep.
And I've had so many conversations with VPs of procurement over my career. And you may argue with them for 2 years between back and forth on your legal teams on terms and conditions about what the penalties are going to be for lack of delivery and any kind of quality issues and things like that. And we're constantly telling people from the manufacturing side, hey, if you can live with very little inventory, us holding very little inventory, very short financial terms, then and very high volumes, very high minimum order quantities, because my production lots are very, very large, then we can possibly talk. But you have a lot of these guys like Automotive that are really high mix, lower volume when you compare it to, say, smartphones. And they're holding a gun to the manufacturer's head and saying, hey, if I don't do business with you direct, I'm going to go to someplace else. And so manufacturers relent. And my conversation with those VPs of procurement would say, okay, I'll relent, and we'll do some business with you direct, but don't be surprised when you guys want product and can't get it. Don't be surprised if I'm not able to provide you anywhere near the value-added services that my distribution partners can offer you. And so there's just this perception that distribution is added cost, and a lot of people think that, okay, well, if I do business direct with a manufacturer, I'm going to get greater priority. Not when they got other backlog in place.
Well, yeah, I mean, what you just covered, there's a lot we can break down into a lot of the industry. Just like, might go back to there's been times in the last 50 years history of the snapbacks or the surges. If you take back my experience was in the .com in late 90s to 2000s. That was math. I mean, tantalums and all semiconductors. It was a big, but then if everything crashed, I think the only difference, because everything that the supply was too much for the demand, everything changed on that. But in this perfect storm that's happened with the pandemic and going 2021, I don't see that we're going to supply and demand are going to have that issue as what we had in 2000, because as you talk about, we're talking about automotive. And I want to tell some of the audience that you can really elaborate is people don't realize that all cars, that's the biggest industry. It's been all over the news. Automotive's being hit $60 billion it might lose this year. But why is because the controllers, they're not using 1 or 2 controllers anymore in these cars.
That's right. They're using hundreds.
Yes. And that has completely taken to the next level of all the new technology. That's why everybody's cars are all digital. Everything is connected. Everything is IoT. So I think that's where we jump into. It's like, okay, is there just automotive is not the only industry. That's just one of the major ones. But why is that? I mean, as you know, coming from one of the semiconductor industry, what do you see now? How many controllers are used? What's happening? Where do you see that going in the automotive industry?
Well, certainly as cars are getting more sophisticated, it's going to just continue to go upward. It's going to just skyrocket, especially as you get to more and more cars having ADAS, automated advanced driver assistance systems, and going towards autonomous vehicles. You just have to have tremendous intelligence in a vehicle to be able to use adaptive cruise control. And just all the cameras, all the sensors around the vehicle that have to transport so much high-speed information back to an ECU, a very powerful ECU that has to be able to crunch all that data and be able to determine whether to accelerate, decelerate, is tremendously difficult problem, both in hardware and in firmware. So, you know, the trends are going to continue to spike in the amount of electronic components. Maybe, you know, at some time, though, that volume will be to the point where they have much more, I'll say, direct influence on manufacturers. But the challenge is that today you look at the numbers. There's about a little over 100 million vehicles built every year, and that seems like a lot. But the thing is, that's spread over more than 100 OEMs and across thousands of tier 1 and below suppliers across, you know, hundreds of thousands of different LRUs that are in and ECUs that are in vehicles. And that means that it's still a high mix business. There's just lots and lots of different designs using lots and lots of different parts. And so there's still a high mix there. And in that case, folks that are buying these components really need to understand that they need to be able to have a healthy supply chain. They need to be able to take advantage of the different options to be able to help buffer parts for them and be able to satisfy their needs in an upturn. You look at it, the estimate that I heard just a couple of weeks ago is that there will be a $60 billion impact to automotive manufacturing because of semiconductor supply in 2021. And that's massive amount of mind-blowing.
It's mind-blowing
of revenue. That's massive amounts of people that are idled. And, you know, having distribution in the game would not have completely eliminated this problem, but it certainly would have cushioned it. And that $60 billion would have been a heck of a lot lower number if really the folks had really planned more accurately.
I agree. I agree. When that goes into the supply chain. So, but as I said, just a couple of questions I have is, automotive is not the only industry also driving. It's just one of the biggest industries. But how about, the IoT world, the 5G, the telecom, the medical, industrial, as everything gets connected, cloud, data centers, everything gets connected.
Right.
And the pandemic has pushed everything digital. So that's why PC sales or laptop sales are through the roof. Peripheral sales are through the roof. And all those need controllers. They all need to have demand. And I would say, my question is that's another huge driver. It's not just automotive. All these together are the massive drivers of why the components are, and because the form factors are getting smaller, the components are getting smaller, everything's getting smaller, and they're asking for, and there's only so much foundries or supply that can produce.
That's right. That's right. Well, and it's not just controllers, like we said. So any controller has to have power, and there's always analog wrapped around that. There's power conversion, there are discretes, there are passives that go around any controller, and the shortages that are happening are, again, somewhat just a phenomenon of this 4-year cycle. But it's certainly exacerbated by the fact that we were starting an upswing. Everything got put on hold for basically 6 months, and then everybody snaps everything back online, and trying to make up for lost time. So it's definitely a serious situation that's going to require some cooperation here over the next 6 to 9 months to be able to get us out of this and to be able to roll forward to that steady state high that will then sustain the business for at least the next couple of years.
Yeah, and that comes to the supply chain, to the systems in play. You touched on some of those points of the manufacturers don't want to deal with it directly to the end user or the distribution, but also is that just in time VM that whole thing, that everything was so lean.
That's
it was
right.
Lean that it could snap. I just say snapped at any time, and this is
lean and just in time works great in steady state environment.
Correct.
When everyone's factories are humming, when all the transportation logistics are steady state. But you look, even transportation right now is disrupted because there's a fraction of the number of planes in the sky. And people say, okay, well, there's a shortage. Well, I need to send this air versus sea, but there's not enough
Cargo
capacity plus the cargo space and the expense goes up. So, just in time and lean manufacturing has to contemplate when things are not at steady state. When you can't run a factory on zero inventory and just in time for forever. Whenever there's a supply chain disruption, then that model is going to really bite you. And again, there needs to be a balanced, pragmatic view of the shortage of a $2 microcontroller versus me not producing that $80,000 vehicle. It's really, really painful for these companies right now, and they'll learn this lesson, and maybe hopefully we don't get amnesia again in the next 4 years.
I mean, you would think with all this technology and AI and smart computing that it could predict some of these things, or at least be conscious of where we're going to be, and this could happen and be prepared for it.
Absolutely. Well, and many companies now are employing PhDs in math. My last company, they had a whole staff of very, very educated guys working on artificial intelligence, machine learning algorithms to be able to figure out how to build. Because, semiconductor manufacturers, they don't want to sit on a lot of inventory either. So they're trying to figure out, how do I build and be able to keep a very high service level and keep my lead times down while minimizing inventory? Because inventory is obviously carrying costs, but it's also comes in scrap. If that material that's in inventory doesn't get bought eventually, then it ends up going into the grinder, and that's a financial write-off for the company. So there's no machine learning algorithm that could have predicted COVID. Certainly, when there are small perturbations in the economic cycles, you can use those as guidance in a machine learning algorithm to be able to help you modulate your wafer starts up and down, and to be able to help you potentially notify even a lot of companies were notifying customers, hey, the demand's getting tight. You really need to put backlog in place. Some customers will believe you and will do that. Others, may ignore you and at their own risk. And so, I think that certainly as we march forward, you get better help from machine learning algorithms, but nothing beats common sense. I don't know of any machine learning algorithm that can outguess somebody that's really got good common sense about how they want to plan their supply chain. And so there has to be a strong balance between those.
Yeah, I cannot agree more. I mean, now coming to the question is from the foundry side. I mean, that's one thing, semiconductors, these foundries, and a lot of the M&As and challenges and the consolidations, and of course the IP as well, is there's, TCMC, UMC, all these guys, SMC, the China fab. A lot of these companies, they produce most of the semiconductor or the fabs in the world. And do you think that's a challenge? Do you think that there's a issue with that there should be more spread allocation? What's your thoughts about that on that?
Well, I'd say I have a lot of respect for the big foundries.
Mhm.
And it's certainly a challenging business model to run because you're having to juggle the needs of so many different suppliers, especially in times like these,
Mhm.
where you have shortages. At the same time, you look at it, it's very, very expensive to build fabs at the bleeding edge. And there aren't many companies that can fork out more than $5 billion for a 5 nanometer fab.
Mhm.
I think that foundries definitely make sense at the bleeding edge, just because it takes the the business levels of multiple semiconductor companies, the size of most semiconductor companies, to be able to basically share the cost of those tremendously expensive production lines. Um, I think that there's still a place for what's called asset light. Asset light means you've got some stuff in foundry, some stuff you're doing yourself, and I do believe there's opportunity. If I put my U.S. citizen cap on, I'd say, okay, from a nationalistic
Yeah.
view, we certainly shouldn't have all of our eggs parked in overseas baskets. That there definitely can be a lot of merit in being able to provide incentives for either semiconductor companies themselves to be able to bring more fabs back to the U.S., to build new fabs in the U.S., or even the foundries to be able to put production facilities in the U.S. At the same time, uh, it's been a pretty efficient model for the industry for now more than 3 decades. It was really the early 80s, mid 80s when fabless
Yeah.
semiconductor companies really started to spring up, when UMC and TSMC
Mhm.
really got into business. Morris Chang's just a genius for the kind of business model that he created. And, you don't have to have everything onshore to have a successful semiconductor supply chain or electronic component supply chain.
No, no, that's good. That's, as I said, I wanted to get that question from someone that in the industry, because it's good to know. I can assume and read, but it's to know how it goes, because the fabless and how costing, because there's a lot of R&D, a lot of challenge, a lot of companies. There's a lot of money, just the equipment itself and running it, billions of dollars, especially when you
Huge.
get.
I mean, some of these
Yeah,
pieces of equipment, a single piece of equipment can cost over $100 million
yeah.
on a fab line today. EUV lithography machines, back in the days when first got to immersion lithography, very, very, very expensive. That it's just very hard for a single semiconductor company to justify. It takes someone the size of Intel or Samsung, Micron, those guys, the real big boys that can afford to do bleeding edge process technologies in house. For the rest of the semiconductor world, it really does make sense to be able to utilize foundry for some portion of your business.
Yeah, I mean, I could not agree. It makes sense, because now it's like 5 nanometer, it's 3 nanometer. I mean, the more the technology, I mean, it's getting to that point where we're getting smaller, and people, I mean, simple don't understand how small, and the form factors of how much powerful a small chip can be. It's mind blowing. As I say, sometimes back in the day, as you say, reference to the Intel Pentium chip. Back then, it was like, oh, it's don't understand that Pentium chip is as big as, if you put discretes, as big as a football field, for example.
Yeah.
How many discrete components takes to build these little chips, and but that's why they're so powerful and what they're doing. But now moving forward to a little other side of the onshoring, offshoring, and some of the challenges too, is like China being a big player,
Mhm.
China having the population to have the massive units, and probably in the future will be the biggest user of semiconductors and components. And how do you see that working? I mean, politics set aside, I mean, do you think that because they have just pure numbers and the usage, they're going to have sometimes a leading edge in that in the future? What do you think? What's your thoughts?
Well, I don't think that the U.S. semiconductor companies, nor the Europeans, or the Japanese are going to cede leadership willingly to the Chinese. I think there's, if you look really just at the U.S. educational system, we're still cranking out some of the best minds on the planet, and so we'll continue to have great innovation and great opportunity. The Chinese are, I have a tremendous respect for Chinese people, a tremendous work ethic, and they are hungry.
Yeah.
So they are absolutely going to be nipping at the heels. Whether they overtake, I wouldn't say that that's a certainty, but they will certainly be getting more and more competitive over the next decade. It's a huge economy.
Yeah.
It will surpass the U.S. economy within a decade or so, and they will have the financial base and probably the political willpower to be able to continue to invest heavily in improving their technology. But I do have a lot of faith in the fact that there's just a tremendous amount of innovative capability in semiconductor and other electronic components around the world, such that China's certainly not going to have a lock on the world's intellectual property. The right thing, if you think about it from a government sense, I can argue for and against some of the things that have happened in the trade war over the past couple of years. You got to hold China accountable. They have to play by the rules. There's absolutely been forced IP transfer for the Chinese government to be able to give foreign businesses access to the Chinese market. And that's not fair. It doesn't jive with the WTO, with their obligations under WTO. It's just flies in the face of fairness and the kind of tremendous government investment in commercial companies also is really flies in the face of the principles in which the rest of the world works under free market economies. So, did the previous administration, did they do the right things? I think they did the right things from the perspective of trying to find ways to hold China accountable and try to make sure that they played by the rules that the rest of the world played, and not stack the deck. At the same time, some of the trade friction that has occurred and the embargoes that we've made certainly motivate the Chinese to be able to try to be less reliant on especially U.S. technology. So, I talked about Huawei and ZTE earlier. If you look back to the time when I was in Asia, certainly they held U.S. technology, semiconductor technology, as number one in innovation, quality, and so forth. Not always pricing, but they appreciated that where they're trying to make innovation, they needed innovative products to be able to help them get there. And they looked at European semiconductor manufacturers and Japanese semiconductor manufacturers, and then really domestic manufacturers were somewhat at the bottom of their list. But now that list has pretty much flipped. Yeah. So if they can find a way to use domestic suppliers to get the job done, it may not be the absolute most bleeding edge product. It might not be the absolute best quality reliability that other international providers could provide, but they know that they're going to have stable source of supply. And what that means is that those Chinese manufacturers that today are much, much smaller than the U.S. suppliers, and certainly much, much smaller the foundries than, say, the TSMCs of the world, they will have revenue to be able to plow into more R&D, to be able to buy more of the best minds, to be able to help them catch up. And so that dynamic will continue to play out. There's no putting the genie back in the bottle, I would say.
I mean, I love that perspective. Your perspective, I mean, it's true. I mean, with all the government regulations, tariffs, IP, As I said, even when I was going there 15, 20 years ago, it was like they're masters at reverse engineering. Not the most innovative, they're just innovative at reverse engineering. They're not the best at actually creating it. They use other people's technology into their products. That's one thing I always say is like the counterfeiting and that stuff really came from there in all the industries. Of course, I think China as well, they created it, but they're sometimes the most strict on counterfeit policies as well. The process and how these companies work, because they're like, we created it, we know how to handle it and mitigate it as well. It's really fascinating on that.
It is. Well, the Chinese have some of the tightest copyright and patent laws and environmental laws in the world. It's selective enforcement.
Correct.
Again, I think that there has to be accountability. There has to be some leverage that we can utilize to be able to make sure that they play by the rules. Yeah. But there's no reversing this trend. And I will tell you, so your comment about them being great in reverse engineering, there's a lot of stories you could point to on that. But I'll tell you, don't underestimate their R&D departments. It's just amazing. You look at Huawei is really the technology leader in 5G. Okay. They got massive MIMO and all of these incredibly difficult concepts to be able to increase bandwidth on 5G links faster than the rest of the world. And they got it into producible technology faster than the rest of the world. So they didn't copy anybody. They didn't pull apart an Ericsson base station, an existing 5G base station and copy that. They're coming up with their own innovations that are very impressive. They've got some really strong minds, and they've got some really highly motivated, hardworking people that again I respect. It's just they got to play by the rules on the international rules on how they conduct their business.
I agree. Now moving forward from there is now this onshoring, offshoring happening from China or Asia itself coming back to the States. How effective do you think? Because with tariffs in place and all this coming into place, can it be a really successful back onshoring? Or is there only certain industries that could come back to the States? I know people go to Mexico or Canada, but coming back to the United States is, I think, a challenge. So what's your perspective on that?
Well, I think there's a couple of dynamics. Number one, if you look at just cost of labor in China, it has gone up dramatically over the last 20 years. Here in the U.S., we're used to getting salary increments in low single digits for the last decade or so. And salary inflation in China has regularly been running, 8, 10, 12% a year over the last 20 years. So where there was massive rationale about taking manufacturing business to China years ago, a couple of decades ago when I was in Asia, it's much less compelling from the cost, especially when you talk about the cost of management. Managers, very strong managers and executive leaders in China are nearly as expensive today as in the United States. So, I think what that means is that things can come back to the U.S. that are less labor intensive, and that may not make union leaders happy. But you look at a modern bleeding edge semiconductor fab, the cost of labor in actually producing a silicon wafer is less than 10%. Oh, okay. It actually is down to the raw materials and the huge capital expenditures that we've been talking about. And so, yeah, you walk the lines of Samsung or TSMC on their 7 nanometer lines, and there aren't many people out there. Everything's automated. All the wafer shuttles move around on overhead conveyors. It's all robotically driven. They put things in and out of ovens. They move them from station to station, and and it's really the manpower on the floor is mostly there for maintenance, calibration, and troubleshooting there, and maybe bringing up new lines. That it's not really highly labor intensive. So if it costs the same amount to be able to put a very expensive lithography machine on the floor in Taiwan or China as it is in Phoenix, then certainly we'd like to be able to have that as U.S. citizens. We'd like to be able to have those closer to home, and I think that there is some opportunity there when you talk about older technologies that and other things that are much more labor intensive. The chances of them going to Vietnam or another low cost area is much greater than it coming back to the United States.
Yeah, I mean, I agree. I agree for that type of production or semiconductor production fabs. It could be because it's a lot of automation is there. But when we go all to the high mix, low volume production and also supply chain in general for components, my perspective is like we can only bring so much, because I would say a lot of the components are still made in China. All the component going into that end product are made there. The supply chain in the US, even though we're innovators and we're the founder of all of this, it's depleted. It's not even here anymore. So to assemble, to have all the contractors, everybody around, and even do a higher volume, you still have to import product. You still have to import product, and there's going to be a tariff on some of that stuff. There's a tariff on it. It raises your cost. It raises all that cost. But that's why I think my things. I'll see Mexico. Mexico is also attractive, but also Mexico needs a supply chain. And that supply chain is still coming from Asia. Yeah. So as much as bringing it back, I think there's a lot of technologies we can, especially the high technologies, but the basic filling boards and basic, electromechanical, these type of things. I think China still has the power of costing because the economics. They do such high volume, they can bring the price down. For management style, it's different, but for the labor, it still is competitive. And now this, India, it's the Southeast Asian, but they don't have the population that China has. So that's also a challenge. And they don't have the skilled workers and knowledge and that culture of evolving they're pushing, for evolution of. So that's the challenges that face into the onshoring, offshoring. But I feel like we should bring more back, but it's going to be segmented of what come back. And
it will be.
Yeah, but as I said, it's a topic that's always comes up, onshoring, offshoring. It's been for the last couple of years, and I'm like, well, what's reality and really what can happen, and then what is can happen just sent to Mexico and still imported and assembled down there. So these are a lot of the discussions that come up, especially local manufacturers, like, oh, we're getting more business back, or we're getting more bidding, or we're getting more. But the skills, knowledge, and skill set of the Asian culture, they have that. PCB, making PCBs, all these type of raw materials, it's still the price point, but now the pandemic has caused logistics to go up. So as we got to that point, when there's less planes flying or less ships, we got the lead times are not only because of component shortages, it's because logistics, there's port.
That's right.
There's a lot in the logistics, and that supply chain has to be improved with. That's why I come into my final question is, what really do you see the future of supply chain or supply chain management in the electronics field? How do you see it evolving in the next 2 to 5 to 10 to the next decade?
I just think there need to be tighter partnerships, and there needs to be much better information flow. The challenge is that, I'll say the analogy that I use. You're a California guy, so it's like somebody hitting the brakes on the 405. And it creates a huge backup in traffic, and everybody's bumper to bumper and cursing under their breath. And you go a mile down the road, and there's no tie up, and you're thinking, why the heck was there this? If it's the same thing in the semiconductor world, you've got these extended supply chains. When you have an OEM that's doing design and program management in multiple locations around the world, and they're going to their contract manufacturer in Asia, different time zone, different language. They're working through a combination of direct business and distribution, but they're not doing a very good job on schedule sharing and so forth. when somebody taps on the brakes, it's going to create that traffic jam. And there has to be a much better, much more efficient way of communicating up and down through the supply chain, better and more willing, open forecast sharing to be able to help all parties understand what different production scenarios look like, to be able to minimize some of the supply chain disruptions like we have in current economy. They won't be able to predict the next pandemic, but certainly I think with much more efficient communication, cloud is becoming a much greater part of our everyday world, in that we have tools that allow us to be able to communicate more efficiently, more real time, with more common tool sets rather than the old bespoke tool sets that people worked on years ago. The SAPs and the Oracles of the world, and integrating the supply chain management and integrating through EDI and other means with your suppliers is going to be just absolutely it's not going to be gravy. It's going to be table stakes, really, 10 years from now, that you're going to have that kind of intelligence and information sharing to be able to be competitive 10 years from now.
Yeah, man. I'm a big fan of Elon Musk, and when it comes to automotive cars talking to each other, transportation communicating with each other, with eliminating some of that traffic and tie up, and then getting the Neuralink and people talk. I mean, the AI and all this going to, and that's really, we are going to get more communication between systems to not, I mean, people will be there, the people are operating the system, but to allow the less disruption or mitigate those disruption and predict. So we don't have these spikes.
That's exactly right. In the automotive world, they call it V2V, vehicle to vehicle. And so if a animal comes out on the road on the 405, and that's the cause of the tie-up, but it's gone shortly thereafter. If you have good V2V communication between vehicles, hopefully that disruption is going to be very minor and very short-lived. Versus what we see today, and I'm sure you can appreciate that. Although during the COVID, certainly you probably have have fewer big tie-ups on the 405.
Well, I think that's one thing that's changed. I mean, it usually takes me 20 minutes, 25 minutes to travel in the morning. Now it takes me 10. So, and it hasn't changed, but that's because digitalization, more the work from home. The efficiencies have gone up in that sense. A lot of industries can work from home, some cannot, but these are the change, and evolution is good. A lot of people have resistance to it, but we're evolving, we're adapting, we're moving forward. And that's how I tell everybody, you can't stop things from changing. Don't think things will happen pre-pandemic and go back to those ways. We're just moving forward. The world's moving forward with or without you. Either jump in, dive in, educate yourself, and get along on that train, as you would say. If not, you're kind of going to be left behind. And that's the challenge of the resistance to change. And
that's right.
That's the biggest challenge. But so what are the words of wisdom for all I would say the new generation coming into the industry? What the semiconductor distribution, representative engineering, what's your words of wisdom for them in this industry moving forward?
That's a great question. I think that it's just really learn as much as you can about all aspects of the business. I was very fortunate in my career. Like I said, I started out as a design engineer and got into sales, and then got into general management and so forth. I always looked for the next bigger challenge to learn. It's not necessarily the next bigger paycheck. It's what different roles can you play in the business to really learn about different parts of the business, what makes it tick. And that's really going to carry you further in your career than trying to just go for the next big promotion in the same line. I was very fortunate through my career to have some really good mentors and some people that were very supportive of these learning opportunities. It wasn't always the most efficient. I wasn't always the best choice. But you just try to find those people that believe in you. Try to be politely demanding is what I say. You gotta manage your own career, and you have to be able to find those supporters and have communicate what your hopes and dreams are so that they can try to be on the lookout to help you find that next opportunity to learn and advance your career. So I've been just tremendously fortunate over my 30 some years in the technology business, and look forward to hopefully a few more.
Yeah, and inspiring others like myself and other people out there. I love it. Staying curious, curiosity and knowledge, and keep learning and learning that whole 365. It's for myself, as I always tell my team and people, and where I got that information is from leaders and people like yourselves. Is stay curious, keep learning, and the more in depth of books and things I read, and everybody has the same message. Just stay curious and keep wanting to get information and learn. You're going to be able to excel into anywhere you are, any career, any choice you go down that road. And that's what it goes into. But well, thank you very much, David. Thank you for this. This was fantastic.
Thanks, Rob.
Lot of wisdom and information from what you've done from the 30 years of semiconductor industry, and all the who's who of the industry, and it's fantastic. And thank you for coming on. And I look forward to in the future doing another one, get some updates from you and the ECIA team, what's going on and the changes. And I wish you guys the best of success.
Good. Thanks, Rob. Same to you guys.
Well, everybody, be smart, be thoughtful, be generous, and we'll see you on the next Real Talk episode. Thanks, David. Bye-bye.
Take care.